Hello students and good afternoon. So now I'm doing class for class 12. The topic is the same topic, that is binary operation. So in the last online class also we were doing the same topic, that is binary operation. So today we'll do more problems on binary operation. So today's exercise is exercise 2B, page number RF, relation and function chapter, from page number 64 from the book Senior Secondary School Mathematics for class 12 by R.S. Agarwal. Right? So let's start from question number 1. So these are all short answer time question. Let star be a binary operation defined by a star b is equal to 2a plus b minus 3. So you have to find out 3 star 4. So this type of question you may get it in objective type of question. Right? So here it is given that star is defined as a star b is equal to 2a plus b minus 3. So you have to find out 3 star 4, right? So here given is a star b is equal to 2a plus b minus 3. So or now instead of a you can write 3, instead of b you can write 4. That is a is equal to 3, b is equal to 4. So on the right hand side also you put a is equal to 3 and b is equal to 4. So 2 into 3 plus what is b, 4 minus 3, which is equal to 2 3s are 6 plus 4 minus 3, which is equal to 6 plus 4 is 10 minus 3, which is equal to 7. So 7 is the answer. So this is the answer for the first question. So I think you have understood it. So next question is number 2. Let's do question number 2. So you can copy it. So let's do question number 2. Let star be a binary operation on the set Q. So here Q is the set of all rational numbers. Q of all rational numbers. You know the meaning of rational numbers, I told you. So defined as a star b is equal to, it is defined as 2a minus b whole square for all a comma b belongs to the set of rational numbers. So you have to find out both 3 star 5 and 5 star 3. Okay. So therefore here a star b is equal to 2a minus b whole square. So or let us find out 3 star 5 first. So here a is equal to 3 and what is b is equal to 5, which is equal to, next it is 2 into what is a, 3 minus what is b, 5 whole square, which is equal to, now 2 3s are 6 minus 5 whole square, which is equal to 1 whole square, which is equal to 1 is the answer. Is that clear? Next you have to find out 5 star 3 now. So again let us write down the definition a star b. So what is a star b out here? This is 2a minus b whole square. Or now you have to find out 5 star 3, right? Now you put a is equal to 5 and b is equal to 3. So if you put a is equal to 5, so it is 5 star 3 is equal to 2 into 5. This is a, 2 into 5, then minus what is b here, 3 whole square. Okay, so which is equal to 5 2s are 10 minus 3 whole square, which is equal to, this is 10 minus 3 7 whole square, which is equal to 49. So this is your 5 star 3. But are they equal? No, they are not equal. So you can write, is 3 star 5 is equal to 5 star 3? No, they are not equal. So therefore 3 star 5 not equal to 5 star 3. So this is the answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 3. if A star B is equal to HCF within bracket A comma B. That means A star B is defined as HCF of A and B. For all A comma B belongs to the set of natural numbers. Capital N denotes the sets of natural numbers. So you have to find out 18 star 24. You have to find out the value for 18 star 24. Okay. So here given is A star B is equal to HCF of A comma B. Okay. So now here you can put A is equal to 18 star 24. That means it is defined as what? 18 star 24 is defined as HCF of 18 comma 24. You can find out the HCF of 18 comma 24, isn't it? HCF means highest common factor. So how can you get the highest common factor? You can divide it also. You have to find out the HCF of 18 and 24. So how will you do it? Let us divide it. Let us do the division method. You have to divide 24 by 18. So 18 ones are 18. So 24 minus 18 is 6. And again you have to divide. Again you have to divide 18 by the remainder. That is 6. So it is 6 3s are 18. So what is the HCF here? So HCF of 18 and 24 is 6. So 6 is the answer. Okay. So I think you have understood it. So your sajilai cha your problem haru haina. So you can do it yourself also. So we'll do next problem now. So now this question number 4 is your homework. So you can do it yourself. If A star B is equal to A square plus B square, you have to find out 5 star 4. So you can do it at home. So question number 5 is let set A is equal to 1, 2, 3, 4, 6. And let A star B is equal to LCM of A comma B. LCM within bracket A comma B means LCM of A and B. For all A comma B belongs to the set A. Okay. So that star is not a binary operation on A. You have to show that star is not a binary operation on A. Okay. If you want to prove that star is a binary operation on A, तो कुनै पनि दुईटाको एलसीएम निकाल्दा फेरि त्यही सेट A मा नै हुनुपर्छ. कुनै पनि दुईटा any two elements A comma B that belongs to the set A, त्यो A comma B को LCM चाहिँ यो set A मै हुनुपर्छ. अनि मात्रै star is a binary operation on the set A. Okay. So here in this case star is not a binary operation. You have to prove it. Okay. So in this case it is given that A star B is equal to LCM of A comma B. Now since in this case if you take 2 and 3, 2 star 3 is equal to LCM of 2 comma 3. So what is the LCM of 2 and 3? 6. That belongs to the set A. Yes, that correct. That is correct. Okay. But what is the LCM of 4 and 6? Let us get it. So therefore 4 star 6 is equal to LCM of 4 comma 6. So you know how to get the LCM of 4 and 6. You can get it, right? So 4 comma 6 को LCM कति हुन्छ? पहिला 2 ले जान्छ. 2 2s are 4, 2 3s are 6. That means 3 2s are 6, 6 2s are 12. What is the LCM of 4 and 6? That is 12. But does it belong to the set A? No, 12 does not belong to the set A. That means this star is not a binary operation. Okay. So 12 does not belong to the set A. Is that clear now? So hence star is not a binary operation. And hence star is not a binary operation. So star is not a binary operation on the set A. यो चाहिँ कति बेला बाइनरी अपरेसन हुन्छ? कुनै पनि कुनै पनि दुईटा एलिमेन्ट दैट बिलोङ टु द सेट ए त्यसको एलसीएम निकाल्दा यही 1 2 3 4 6 नै आउनु पर्छ either it should be 1 or 2 or 3 or 4 or 6 other than this अरु नम्बरहरु आयो भने चाहिँ that is not your binary operation. So I think you have understood it. Since here 4 र 6 को LCM कति भयो 12 भइगयो तर 12 त यो सेट A मै छैन 12 does not belong to the set A, so star is not a binary operation on the set A. So I think you have understood it, so you can copy it. We'll do the next question now. So now we'll do the next question, that is question number 6. Let z plus be the set of all positive integers. तो यहाँ z plus से के दिएको छ set of all positive integers plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 etc. And let star be a binary operation on it defined by a star b is equal to within modular sign it is a minus b. Okay, for all a comma b belongs to z plus. So you have to find out 3a star 2b where a is equal to minus 5 and b is equal to minus 6. So let us do this problem now. So what is given out here? Your given is, so a star b is equal to within mod a minus b. So you have to find out the value for 3a star 2b when a is equal to minus 5 and b is equal to minus 6. So instead of a you write 3a star, instead of b write 2b which is equal to within mod. So instead of a you have to write 3a minus, instead of b you have to write 2b. Okay, so which is equal to, now what is the value for a? 3 into minus 5 minus 2 into what is b? It is minus 6. So let us find out the value of this expression. So is equal to within mod, this is minus 15 minus 1 minus plus, that is 6 2s are 12. So which is equal to within mod minus 3, which is within mod minus 3 means which is equal to plus 3. So this is the final answer. So I think you have understood it, so you can copy it. Now we'll do the next question. So now we'll do question number 7. The question number 7 is let star be a binary operation on capital N. Here capital N is the set of natural numbers. That means it starts from plus 1, plus 2, plus 3, plus 4 and so on. That is all positive integers are known as natural numbers. Okay, defined by a star b is equal to a to the power b. So here a star b is defined as a to the power b. For all a comma b belongs to the set of natural numbers. You have to show that star is neither commutative nor associative. So you have to prove that here star is neither commutative nor associative. Okay, so now here given is a star b is equal to a to the power b. For commutative property we have a star b is equal to b star a. Okay, so if a star b is equal to a to the power b, so what is b star a? So b star a means instead of a there is b, instead of b there is a, so it is b to the power a. So are they equal? Since a to the power b may not be equal to b to the power a to the power b is not equal to b to the power a. For all a comma b belongs to the set of natural numbers. Okay, so which implies that a star b not equal to b star a. So therefore star is not commutative. So star is not commutative. So I think you have understood it. Now for associativity, you know that you have to prove within bracket a star b bracket close star c is equal to a star within bracket b star c. Okay, so now therefore let us find out first A star B star C. So now first of all, you put the value for A star B. What is A star B? It is A to the power B. Now star C, isn't it? So A star B is given as A to the power B. So this is your A to the power B. Okay. Next, now you can take A as A to the power B, here B as C. You A to the power B बनेको A हो, you C बनेको के हो B. So how is it defined? It is A to the power B. That is, it is A to the power B is A here, whole to the power B means whole to the power C. So which is equal to A to the power BC. That means we get A star B within bracket and star C means which is equal to A to the power BC. That is, in this case, here A is A to the power B and here B is C, which is equal to A to the power B. A star B is defined as A to the power B. So in this case, A to the power B is A, write it within bracket, whole to the power, you can write C. That means you can multiply these two power A to the power BC. Is that clear? Next. Therefore, now we have to find out A star within bracket B star C. B star C. So which is equal to A star is kept as it is. What is B star C? Instead of A there is B. Instead of B there is C. So A star B is A to the power B. So what is B star C? It is B to the power C. Is that clear? यहाँ A को जग्गामा यहाँ के आयो? B आयो, B को जग्गामा C आयो. तो A to the power B भनेको कति हुन्छ? B to the power C. Is that clear? Now again, instead of A there is A and instead of B there is B to the power C. So it is A to the power B is there. A को जग्गामा यहाँ A नै छ, तर B को जग्गामा यहाँ के छ? B to the power C. But A star B is defined as A to the power B. So in this case it is A to the power B to the power C. That means these two are not equal. You the B to the power C. This is A to the power B to the power C. But here actually it is A to the power B whole to the power C. You can multiply these two, isn't it? That is BC. But A to the power BC is different from A to the power BC. That means since A to the power BC not equal to A to the power B to the power C. So therefore within bracket A star B star C not equal to A star within bracket B star C. So I think you have understood it. This expression is not equal to this expression. That is, star is not associative. So therefore star is not associative. Therefore star is not associative. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 8. Let A star B is equal to LCM of within bracket A comma B. So in this case, this star operation is defined as A star B is equal to LCM of A comma B for all values of A comma B belongs to capital N. Capital N means set of all natural numbers. So question number 1, you have to find out 12 star 16. That means you have to find out the LCM of 12 comma 16. Okay. Number 2, you have to show that star is commutative on natural number. Number 3, you have to find out the identity element in N. And number 4, you have to find out all invertible elements in N. You have to find out all invertible elements in N. Okay. So let us find it now. So number 1. So A star B is defined as LCM of within bracket A comma B. Okay. So next, Therefore, so instead of A, you have to write 12. 12 star 16 is equal to LCM of 12 comma 16. So you know how to get the LCM of 12 and 16, isn't it? So 12 comma 16. So first of all 2. So you can divide it by 2. 2 6 are 12, 2 8 are 16. Ferry, you can divide it by 2. 2 3 are 6, 2 4 are 8. So now you can stop out here. So what's the LCM of 12 and 16? So 4 3s are 12, isn't it? 12 2s are 24, 24 2s are 48. So which is equal to, what is the answer? 48 is the answer. I think you have understood it. So 48 is the answer for the first question. Okay. So now next, number 2. So what is number 2 out here? You have to show that star is commutative on n. That is, you have to prove A star B is equal to B star A, right? Now here, A star B is equal to LCM of A comma B. And you know that LCM of A comma B is equal to LCM of B comma A, same thing. That is, LCM of 12 comma 16 is 48. So LCM of 16 and 12 is also 48. LCM of 12 and 16 is 48. So LCM of 16 and 12 is also 48. So like that, LCM of A comma B is equal to LCM of B comma A. That is LCM of B comma A. That means here it is defined as what? Now B is written first. So B is star. You have to write A. So it is commutative. So star is commutative on n. So therefore you can write here, therefore star is commutative. So star is commutative on n. So star is commutative on n. So that is the answer for the second part. Now let's do number 3. So now number 3, you have to find out the identity element in the set of natural number for this definition, right? So here the definition is A star B is equal to LCM of A comma B. So let us assume that let E belongs to the set of natural number, be an identity element. Be an identity element. So for A belongs to the set of natural numbers, therefore A star E is equal to E star A is equal to A. Is that clear? So A star E is defined as what? So A star E is defined as what? A star E is defined as LCM of A comma E. So LCM of A comma E is equal to LCM of, what is E star A? So E star A is defined as LCM of E comma A, which is equal to A. So now in this case, LCM of A comma E should be A, or LCM of E comma A should be A. When is this possible? You कति बेला possible हुन्छ? When is this possible? So when E is equal to 1. Okay. So if E is equal to 1, then LCM of A and 1 is, then LCM of A and 1 is A. If E is equal to 1, then LCM of A and 1 is A. E is equal to 1, then LCM of 1 and A is A. That is, what is the identity element in N? That is 1. This 1 belongs to the set of natural numbers. Therefore, identity element in N is equal to 1. So this is the answer. So I think you have understood it. Okay. Next, let's do number 4. So let's do this question number 4 now. Now you have to find out all the invertible elements in N. So what is the inverse? What is the inverse or invertible element in the set of natural numbers? So in this case, okay. So here let B be the inverse of A. Let B be the inverse of A. And here A belongs to the set of natural numbers and also B belongs to the set of natural numbers. Let B be the inverse of A. That is, A belongs to the set of natural numbers and B belongs to the set of natural numbers. Okay. So now you know that A star B is equal to, from the definition of inverse of an element, we have, from the definition of inverse of an element, we have A star B is equal to B star A is equal to E. Okay. So now what is A star B? It is defined as what? LCM of A comma B is equal to LCM of B comma A is equal to, what is the identity element here? 1. So if LCM of A comma B is 1 or LCM of B comma A is 1, when is this possible? When is it possible? When A is equal to 1 and B is equal to 1. So this is possible. This is possible if A is equal to B is equal to 1. So hence 1 is the invertible elements in N. Therefore 1 is invertible elements. 1 is invertible element in the set of natural numbers. So this is the answer. So 1 is the invertible element in N. Only 1 is the invertible element in the set of natural numbers. So I think you have understood it. So you can copy it. Now we'll do the next question now. So now these two questions are your homework. That is question number 9. So this question number 9 is your homework. Question number 9 is, let star be a binary operation on R minus, within second bracket, minus 1 is given. So what is the meaning of this one? That is, in the set of real numbers, minus 1 is excluded. Actually minus 1 is a real number, but in this problem this minus 1 is excluded from the set of real numbers. So यो real numbers मा चाहिँ minus 1 अब पर्दैन. ठीक छ? Defined by A star B is equal to A upon B plus 1. किनभने set of real numbers मा B is equal to minus 1 भयो भने यो minus 1 plus 1 के हुन्छ? 0, which is undefined. That's why it is given that minus 1 is excluded from the set of real numbers. Is that clear? So A star B is equal to A upon B plus 1 for all A comma B belongs to the set of real numbers minus minus 1. That is, minus 1 is excluded in the set of real numbers. Okay. So you have to show that star is neither commutative nor associative. The star यो जुन चाहिँ operation star छ यो commutative पनि हुँदैन, associative पनि हुँदैन भनेर तिमीले प्रुभ गर्नुपर्ने छ. ठीक छ? त यस्तो टाइपको क्वेशन हामीले गरेका छौं. You can do it at home. Okay. And this question number 15 is also your homework. So if star be a binary operation on the set Z of all integers, here Z is the set of all integers. It may be positive integers, it may be negative integers including 0. Okay. So star be a binary operation defined by what? A star B is equal to A plus 3B square, comma, you have to find out 2 star 4. So I think you can do it. 2 and 4 belong to the set of integers. So using this definition of A star B is equal to A plus 3B square, you have to find out 2 star 4. So I think you can do it. So this much is for today. So you revise all the problems that we did today and all of the problems that we did in the other online classes also. So in the next class, we will do more problems on this binary operation. So this much is for today.